Well, it turns out my factoring plan was a little overambitious. I thought it would just because my numbers ended up so nice, but I ended up having to put it in quad form. They won't necessarily, I've never seen them make you use quad form on the AP test. They work it so that you don't. But if you have to, you just do the opposite of B plus or minus the square root of B squared minus 4 AC all over 2A. And you can do that, and I think that you know that formula, and so you could do it, but we never had to. Anyway, we get the time is equal to 3.7 seconds, and that's the one thing that transfers back to the y side. That definitely needs to be on your note card. So I take my time, I put 3.70 on the x side. Now I have enough to solve for distance, and I do that by using the equation that has these in there. D equals v1t plus 1/2 at squared. My distance is what I'm solving for. 8.66 times the time, which is 3.70, and I get that my distance is 32.04 meters. That problem of finding how far from the base of the cliff is on a lot of AP tests, so make sure you understand that. It's not so bad, it's pretty easy, but you do need to know it. This last one is the most complicated of them, and remember on AP tests that's generally how it works. We get more complicated as we go. And this one, I'm going to have my cliff, I fly off of it, and I want to know the speed there at the bottom. And to do that, I'm going to make my two columns, x and y, put my numbers in. I know that my v1 in the x is 8.66. I know that my v1 in the y is 5. I know that a is always 0 on that side, a is always negative 10 on this side. And this time, I could put in the numbers that I'd found out, right? I could put in the distance that I solved for there, and I could put in the time, but I want the fewest things possible, so I'm only going to put in the ones that I know first. And this one over here, the thing that I know first is the distance is negative 50. I could put in the time, but I want to use the fewest calculated things possible. Since I'm trying to find out what the v at the end is, I'm going to have to find both the vy and the vx, and I'm going to have to add them as vectors. So that's the hard part. The nice thing is that on the x side, since the acceleration is 0, my velocity stays constant. I could say that v2 equals v1 plus at. I'm looking for v2, and since that all goes to 0, v1 equals v2. So my v2 here is 8.66. Oops, that's not a 6. On the y side, I'm going to actually have to solve for v2, and that uses a different equation. My last equation is v2 squared equals v1 squared plus 2ad, and I know that v2 squared, which is what I'm looking for, is equal to 5 squared plus 2 times negative 10 times negative 50. And then I get v2 equals 32.02. Now I want to take those two things and add them together as vectors. So remember, I have to set up a triangle for this. I know this side of the triangle is 8.66. That side is 32.02, and I want this side. That's c, and then I also need the angle because it's a vector. So I do a squared plus b squared equals c squared. 8.66 squared plus 32.02 squared equals c squared. I get to my c is 33.17. And I say that the tangent of theta is 32.02 over 8.66, opposite over adjacent. And then to get theta by itself, remember I have to do this tangent negative 1 to this side, but I have to do it to both sides. So in my calculator, I type in tangent negative 1 of 32 over 8.66, and I get that the theta equals 75 degrees. So my final answer is 33.17 meters per second, 75 degrees below horizontal. Now, it turns out that this particular problem, when I'm trying to find the velocity down at the bottom, would have been easier with energies. I could set mgh plus 1 fmv squared equals all of 1 fmv squared at the bottom and get the answer a lot faster, but since I'm doing 2D kinematics, I'm going to show it to you this way. Alright, that's it.